Hi, this is Dr. Matthew Giobbi. Welcome to part 3 of Traditional and Neuromarketing, a media psychology investigation. We're going to begin today talking about neuromarketing. Neuromarketing's been the buzz over the past few years. I think it reached its peak, although we still hear a lot of reports on it. And so we're going to look and discuss what is neuromarketing. We're going to discover what are the large private for-profit companies, the marketing companies that are prominent in the field. We're going to take a look and see which research universities have neuromarketing labs for consumer psychology. We're going to understand the difference between neuromarketing and consumer psychology. So in other words, one's an academic study, the other is a business pursuit. We're also going to look at some of the major and most talked about studies in neuromarketing. We'll critique those studies. We'll see if neuromarketing is what conclusions we can draw about it, if it's truly an effective marketing tool, what are the ethical implications involved with it, and or is it perhaps something that is more hype than substance. But to begin with, we're going to take a close look at neuroimaging and neuroscience. So we're going to have a bit of a primer on how neuroimaging works, how to interpret some of the major neuroimaging tools, how most neuroscience studies are set up. So we're going to take a in-depth look at the nuts and bolts of neuroscience first. And we're going to begin this endeavor by considering neuroscience as a whole and then shifting into how it's been applied to neuromarketing and consumer behavioral psychology. As we've seen throughout the history of marketing and the history of psychology, there has been some intermingling. We've seen that this, in our previous lectures, we've seen that this has occurred early in the history of psychology. We looked at John B. Watson's role in advertising, the psychoanalytic role in advertising with the Hidden Persuaders book discussing much of the psychoanalytic influence. And also we have cognitive psychology with behavioral consumer studies, etc. Neuromarketing is simply neuroscience, called neuromarketing, is simply the latest installment of this relationship. And we have a definition that I found that I believe is probably the best definition. And this is Stephen Genko. Neuromarketing is a new field that is rapidly emerging in the world of consumer research. For some observers, it's the holy grail of research technologies that will finally unlock the mysteries of a consumer choice and behavior in the human brain. For others, it's the root of all evil that will finally give marketers and advertisers ultimate control over our minds and pocketbooks. So which is it, holy grail or root of all evil? This is the question he poses. We can look at the attraction of marketing to the attraction of neuroscience to marketers is really one of discovering, again, what they describe as unknown motivations, like bypassing the middleman of the consumer and going directly to the brain and treating the brain almost as its own homunculus that makes some sort of decisions independent of the person. And this really doesn't seem too different from the old model of psychoanalysis. Whereas neuromarketers will talk about often the reptilian brain, psychoanalysts discuss the id, the biological drives. And the midbrain, of course, is discussed in biological psychology of the drives for these drives that can be tapped into in marketing. But really, if they were turning to if psychoanalysts were promising to get to the unconscious motivation of buying, neuroimaging and neuroscientists of neuromarket research are promising some sort of scientific, biological-based, for lack of a better term, unconscious, or could we say not conscious motivation for decision making and purchases. And really, we have to remember that neuromarketing, like its parent endeavor, neuroscience, relies on the bedrock is three philosophical concepts. And those concepts are reductionism. That means that social and personal processes can be reduced to cellular, tissue, and chemical levels, and even subatomic levels of physical material. So this is also the second description, materialism. The second assumption of neuroscience is materialism, that all phenomena can be reduced to a physical substance. That's materialism, also called physicalism. And finally, mechanism, the idea that somehow the human biological system works like a clock. We call this a clockwork system, and that with enough study, the patterns of this clockwork will be understood in a regular way to predict, control, and change behavior. So these are really this is the premise of neuroscience. I asked the question: Is neuromarketing just advertisers marketing advertising? And that's where we're going to. This is the third option. Is it good? Is it bad? Or is it really inconsequential? So let's take a look at a few examples of how neuromarketing's been used. Perhaps some of these commercials and advertisements you will be familiar with. Here's one we'll take a look at. Cheetos Plain commercial. It comes from a series of Cheeto ads.
Kimberly, you've got the tools to fix this. Double down. Rock-a-bye, baby, in the treetop. When the wind blows the creep.
So this is a Cheetos Frito-Lay commercial that ran in 2008. And this is a commercial that did air primarily because of neuromarketing or neuroscience research. And to explain this, they found that EEG patterns, so electroencephalogram patterns, indicated a sense of giddy subversion that consumers enjoy over the messiness of the product. So neuromarketers and individuals who know how to use electroencephalogram technology, EEGs, measured brain waves while test consumers watched the commercials, and they decided that there was evidence through the EEG brain patterns that were displayed that the customers, and incidentally those customers were primarily women, so this series of commercials was targeted towards women. They feature women, took great pleasure in subversion and the messiness of the product. When we see the actual study, Frito-Lay Chief Marketing Officer Ann Mukherjee said that the brain imaging tests were more accurate than the focus groups. So they showed these advertisements to focus groups. In particular, there was one in which there was a woman in a laundromat, and she took revenge on another person's laundry, someone who had done something to her. She took revenge on her by putting Cheetos in her laundry, in her white laundry, which stained it all orange. The focus group folks, in other words, with this traditional method of acquiring knowledge, would be to have 30, 40, maybe even 100 people watch the commercial and then ask how they feel about the commercial. They said they didn't like the commercial. They felt that it was, maybe they didn't want to look mean-spirited or something, but the EEG tests showed that they actually had brain activity that the neuro researchers determined meant that they actually enjoyed the commercial. So In another research study, this one done at Emory University, um, the researchers Burns and Moore took teenagers, put them in fMRI machines. So these are functional magnetic resonance imaging. This gives millisecond by millisecond snapshot of active areas of the brain. And they played different songs, and they found that, according to their interpretation of the research of the fMRI findings, that the pleasure centers, areas that they felt were pleasure centers, were active when listening to the One Republic song "Apologize," which would indicate and predict that it was a hit. And these researchers are suggesting that they can neurotest songs before the release to know what song is going to be a hit and which songs are not. The last quote here is very interesting. Importantly, Burns and Moore also asked their original study participants how much they liked the songs they heard, but those responses were not able to predict sales. Carmarker's note states, illustrating the marketing value of subconscious cerebral data. So again, here we see this concept that we saw during the psychoanalytic craze of the 1930s, 40s, and 50s, even into the 60s, the psychoanalytic craze of tapping into an unconscious. In here they use this term subconscious out of the context of psychoanalysis, but really they're looking for this idea of a biological shortcut to get people to purchase an item. And another example, Frito-Lay unit uses neuromarketing quite a bit, as it's part of PepsiCo, Pepsi Cola Company. And they found, not surprisingly, they found that the shiny potato chip bags, the snack bags of potato chips that had a glossy, shiny surface, like potato chip bags traditionally have, activate this area of the brain called the anterior cingulate cortex. And this is an area of the brain that's associated with feelings of guilt. And they found that the matte bags, in other words, non-glossy bags that were kind of flat, it's called matte, it's a non-shiny, more papery, it looks almost like a more organic finish, didn't activate the anterior cingulate cortex as much as the shiny bags did. So they interpreted this as meaning that it made people less guilty to buy snack foods from the matte bags and the shiny bags. This is a very cited example that we're going to come back to in the future, because this is one in which I'll introduce a concept later called neuroredundancy, and that is these are studies that expensive neuroscience research, neuromarketing research is extremely expensive, but a neuromarketing research study can tell us this, but so can a traditional study of just interviewing people who will subjectively tell you, yes, it's a matte bag, is more organic associations with it. So neuroredundancy is the idea of when neuromarketing is expensive, neuromarketing is used when traditional, much less expensive means could be used to get to the same results. So that's referred to as neuroredundancy. As a side note, we'll look at that later. But this is another example of how Frito-Lay uses neuromarketing. So let's begin with the tools that neuromarketers are using, and these are the prominent tools of neuroscience. We begin with the earliest technology, electroencephalography. So an EEG is a very common way of measuring electrical activity on the surface of the brain, the cerebral cortex. And this technology is very inexpensive today. Anyone, including yourself, could afford a basic EEG set, and there's also open source software to to interface with the computer through a USB port. So basically, today, a high school student could purchase the technology for EEG and learn how to use it. There are even schematics online to build your own. So EEG is one of the earliest technologies for measuring electrical activity in the brain, so brain waves. And the technology dates back to the 1870s, believe it or not. And it still is and remains the most economic and affordable way to measure brain activity. Its limitations are that it gives a readout for electrical activity, and it's limited to the surface of the brain, to the cerebral cortex, not the deep structures of the brain. So you don't get a picture of the brain or any type of representation. You get wave patterns, electrical wave patterns. So the EEG, incidentally, turns out to be the most widely used tool for neuromarketing today, mostly because it takes relative to the other neuroimaging technologies, it takes less training, less understanding, and education to use the instrument, and it's also extremely affordable in comparison with the multi-million-dollar devices that we're about to take a look at now. In the 1970s, CAT scans came on the scene. They're referred to as CAT scans, CT scans. It stands for computerized axial tomography. And this was the first device that really, widespread device that enabled neuroradiologists to see the ventricles and distinguish between the tissue and the ventricles. White tissue, gray matter, white matter, gray tissue, gray matter. And to look for things such as tumors, but these are static images. They're snapshots. They're, in essence, X-rays of the brain. And taken together with MRIs, magnetic resonance imagery, which we're about to discuss, these two remain two of the biggest, or most widely used static images to look for things such as brain tumors, lesions, any type of damage in the brain, or static abnormalities. So in other words, things, it's not showing activity in the brain, it's showing material X-ray of the gray and white matter and the ventricles. In the 1980s, we saw the onset of PET scans, or positron emission tomography, and these computer neuroimaging devices were much different than anything that came before, because this enabled the radiographer to see where metabolism of glucose was taking place at the brain, within the brain at any given moment. So it was almost like a streaming record of what area of the brain was consuming energy, was digesting glucose, metabolizing glucose, energy in the brain. And through a series of statistical means, which we'll discuss in a little bit, these colors were used to represent the brain activity. So this shape that we see here, this isn't an actual image of the brain. It's not a photograph. This would be a computer program that just gives this shape to any anyone's brain that's in the PET scan. And then there's just this general area in the brain, and it's a three-dimensional image. And when there would be metabolism, higher rates, it would be statistically generated to be visualized on the computer as the color red. And the lower areas, the areas that weren't consuming as much metabolic digestion, would be assigned a color that would be a cooler color, like blue or green. So it's not like the brain, this is a picture that you actually see these colors in the brain. It's a statistical representation in color of the areas of the brain that were metabolizing glucose more than others. And again, this is not a picture. This is a computer form that is used, and the red might just be a color representative of say, the number 100, whereas blue might be the color representative of the number 10 or 20. So it's simply assigning a color to a level, a higher or lower level of metabolism is taking place. The thing that was really revolutionary about the PET scan was that and it continues to be one of the more used ways in neuroscience, was that you could see at any given moment where the activity, where the brain activity was taking place, where the function was taking place. Now that doesn't necessarily equate to brain localization. So in other words, it doesn't mean that if this area is lit up during a visual task that this is where vision is processed. This is a very complicated discussion to have, but that we're going to be getting into in more depth. But it turns out that individuals who may be more habitually doing something, so say talking while playing the piano, their brain, because of the habit, that's such a high level of training, their brain would take much less activity and energy to do the task. So simply saying that this area is the brightest, so that's where it's processed, could be very misleading to make that assumption. So we move forward to MRIs and fMRIs. So magnetic resonance imaging and functional magnetic resonance imaging, which came into prominence in the 90s and has really been the technology that kick-started neuroscience. If we could point to one technology, fMRI is definitely it. So magnetic resonance imaging is a three-dimensional X-ray, a snapshot. So it's static, like the PET scan. An fMRI is functional, meaning it takes a millisecond to millisecond stream, a millisecond to millisecond image change, which means you can add time to the dimension. So this is a typical fMRI. I'm just going to quickly explain how an fMRI works in its most basic way. Each, when you see an image, you can either, the image atypically is of a person. Typically, when you see these images, it's a composite of maybe 100 subjects or 40 subjects, 40 brains, and which you're not actually seeing, like in research studies for fMRIs and also for some of the PET, for the PET scans, PET scans, and MRIs. You're often seeing a composite of subjects, so it's like an average brain of activity. It's not typically one brain that you're seeing, but you can see just one brain as well. When each of the technology goes like this: when an area of the brain is active, it's consuming oxygen, and when it is less active, it consumes less oxygen. So there's something called the blood oxygen level dependent response. It's referred to as BOLD, blood oxygen level dependence. And basically what happens is the technology will take a reading of the brain, of the person's brain at stasis, so at a baseline, and then will take and gets a reading of what the BOLD reading, the blood oxygen level, is in that area of the brain, and then we'll compare that to changes in BOLD changes, blood oxygen level dependency changes during a task, say, I don't know, reading a book, solving a math problem, speaking, etc. And they'll get a statistical difference between the two BOLD readings, the baseline and the in use. That goes through a statistical program which turns that difference into a number. That number is then turned into a color. You see these colors here. At the top is 12.35, and down here is 4.35. So each of these would show an intensity of BOLD, of oxygen levels as compared between two states, a rest state and an active state. And in that way, the image that you see, so in other words, the brain doesn't actually light up with colors when one's thinking or when it's active. This is just showing where oxygen level is taking place, and it's represented, instead of numbers, it's being represented by colors. So the logic goes something like this. Simply an example would be, they'd have, if you want to understand which areas of an individual's brain are active while reading aloud, you might take the individual at a silent state, reading silently to themselves, and record the brain image. then re-record the brain image with the individual reading aloud, then overlay those, subtract the areas that are used together, and the remainder of the areas that are active would be the area of the brain that's active when reading aloud. It's just an example given for understanding how the fMRI works. So each of these areas of the bold data, each of the area of the brain has a certain pinpoint. In other words, like a pixel. Cameras have pixels, and fMRIs have something similar to pixels. They're not called pixels; they're called voxels. And a voxel is a level of volume of oxygen present in an individual point in the brain. So like a pixel on a camera image, a voxel is it's actually about 3 cubic millimeters, and the typical brain could be divided up into about 50,000 of these little areas, and each one of those little 3 cubic millimeters of voxels are what makes up the colored images that you see on the screen. Now keep in mind how many neural connections are in 3 cubic millimeters. This is just to give you an idea. When you're looking at these images, you're not seeing synaptic firing at the cellular level. It's much grosser than this. It's much bigger. It's a 3 cubic centimeter. One little dot of color, 1 pixel is 3 cubic millimeters. So this is relatively speaking, this is a very crude measure. It's not going down to like the synaptic level or even the cellular level. So these voxels are like pixels. These are the things that are actually assigned a color code depending on the volume of oxygen that's present at any given moment. So here are some of the major brain areas of interest in neuromarketing in particular. The limbic system. So this whole area here, of this limbic system area, emotions, memory. These are all of interest to neuromarketers. They're looking for activity in the limbic system, which indicates memory and emotion. They're looking at the anterior cingulate cortex, the ACC. This is really thought of to be a guilt center of the brain. Now, if you look at, these are just two of the major areas that are often discussed in the literature. If you look at these, the pleasure areas in the limbic system that can activate, and the guilt systems in the ACC, there's a technique called reverse inference, and reverse inference is really at the core of most neuroscience research, and certainly at the core of neuromarketing research. And reverse inference is problematic because it suggests, the way the research is done is there's a backwards reasoning. In other words, an individual claims a subjective experience, and when that subjective experience is spoken, the researchers will look at which area of the brain is functioning at that time. And the reverse inference means that if someone is feeling guilty when the ACC is active, that must mean anytime the ACC is active, guilt is experienced. Now here's the problem. Something like the ACC, the limbic system, guilt isn't the only thing that is processed in this area. So you could have a multiple, to give an example, there could be a multiple of subjective experiences that are correlated with any given area of the brain. Think of it this way: when pupils dilate, it doesn't necessarily mean that someone is interested. It could mean that they're scared. It could mean that they are very much interested in you, or infatuated with you, or in love with you, or stimulated by you. It could mean many different things. It could mean fear, it could mean infatuation, etc. So this is just pupil dilation, a biological reaction. So reverse inference is when an individual makes a claim, a researcher makes a claim that because this area of the brain is lit up, it means this specifically, and that is problematic. The research just doesn't pan out in this way because the brain areas are very complex. Most of these brain areas will process many different subjective feelings and emotions, not just one. So leaving it to the interpretation, a neuromarketer could make claims that might not be as real as they might appear. So reverse inference is a big, sticky philosophical issue with all neuroscience research. For an example, the insula. The insula, from your book, it says the insula has at least 10 anatomical subunits, each within its own population of neurons and specialized function that play roles in a broad range of experiences such as trust, sudden insight, empathy, uncertainty, aversion, and disbelief. Researchers have also linked the left hemisphere insula to the quality of orgasm in women. Like most brain areas, the insula is a paired structure with one on each side. Most striking, the insula helps mediate awareness of bodily sensations. It integrates visceral states such as pain and hunger, thirst and temperature, and thereby contributes to the conscious experience of emotion. So when you look at something like this, in one study they found that the insula was active when female voters saw Mitt Romney, the Republican presidential candidate Mitt Romney, and they were saying, well, did this mean that they liked him, that they were afraid of him, or that it was just something new? Was it sexually exciting? There were so many conclusions that could be drawn from this insula from the activation of the insula, to draw one specific conclusion that this means this is problematic in neuroscience and in neuromarketing in general. Okay, so we're going to take a look on page 14 of Sattel and Lilienfeld's book, Brainwashed, The Seductive Appeal of Mindless Neuroscience. They give us a number of warning signs of things to really be careful about. Number one, they said, whenever you see a newspaper headline that proclaims brain scan shows, be careful, because most of what's presented by science journalists and by PR departments from universities and research institutions are not interpreted by neuroscientists themselves, and due to two incidents, two specific reasons, this is awfully misinterpreted and vastly sensationalized claims. Basically, when you see a headline that tells you that some area of the brain has been located, be very skeptical of this. There are so many reasons why this is very improbable, and neuroscientists do not make claims like this. At least most don't. Some overzealous ones do, but the most responsible neuroscientists will use words like associated with or correlated with, not caused, because they understand that the brain area function is a correlate with the experience, with the phenomenon, with the activity. It's not a cause and effect relationship. Firstly, whenever you see this X causes Y headline, this is either an overzealous PR department, in other words, the university publicity looking to make some news waves for the university, prestige reasons, or for the institution, the company, or it is sloppy science journalism, and there is a lot of sloppy science journalism. We have daily on blogging and on newspaper and internet sites, we have individuals who have degrees in journalism. The journalists know how to write in a very convincing and authoritative way, and they do so. However, they don't have an authoritative knowledge of the things they're writing on all of the time, and neuroscience is definitely one of those things. So you will often have someone who has an undergraduate degree in journalism, or maybe a graduate degree in journalism, writing on science and maybe minored in science or double majored, but have perhaps an undergraduate understanding of what the science means. And occasionally there are good science journalists, but a lot of it is sloppy science journalism. Whenever you see the area of the brain located, that's sensationalized. It's very unlikely that that's going to happen. There's a variety of reasons for this. The brain's also is constantly changing is one of the reasons. The brain interprets subjective experience human experience is not only experienced differently from individual to individual, but from culture to culture. Enthusiasm, excitement, interest, joy are expressed and processed differently in brains of people of different cultures. And that's generally speaking, and specifically speaking, brain to brain, individual to individual, expresses joy and exuberance and sadness and sorrow and disgust in vastly different ways. And that's represented in vastly different areas of the brain and ways of the brain functioning for each individual. So we're talking about very individual. Will brain mapping ever occur? In our lifetime, no. That's my prediction. However, when it does occur, it'll be occurring on the individual level. You'll be able to somehow map a brain relatively, although the brain is constantly changing, but on an individual level. But there is no brain mapping on a mass scale. No two human brains are functioning in an identical way. So no two people think in identical ways. Second, the subtraction technique used in most fMRI experience are not well suited to the questions being asked. Recall that the assumption behind the subtraction is that two mental task conditions differ only in a single cognitive process. However, most mental operations seem like a unified task are compounded of many smaller components. So in other words, when an fMRI for a certain task is singling out a distinct area. When a neuromarketer says this area is lighting up, this is an active area, therefore it means this. The process that takes place in processing anything is done through networks of areas of the brain, not through an area of the brain. And those networks change from individual to individual, from cultural to culture, etc., from cohort to cohort. So this is another major issue that our neuroscientists, Sally Satel and Scott Lilienfeld, warn us against when we're looking at this information. Thirdly, they warn, although neuroimaging has deepened our knowledge of brain anatomy and function, its popular application tends to reinforce the misbegotten notion that the brain is a repository of discrete modules that control distinct capacities to think and feel. This is not the case. Studies that suggest that a brain spot for X are typically misleading because mental functions are rarely localized in one space in the brain. This is something I just touched on. A fourth caveat to keep in mind, they say, is that when one is interpreting the brain scans, it is important to look at the design. So if you have individuals who the design itself, the design of the study, the way, in other words, the neuroimaging is being used in an experimental setting, could affect the results of the study itself. So in one famous study, in 1999 at Harvard, some teens were asked to look at a series of black and white photos depicting frightening faces. They mischaracterized 1 in 4 photos, sometimes seeing anger, surprise, or confusion, or even happiness instead of fright. Regardless of whether they correctly identified the emotions as fear, subjects displayed significant amygdala activation. So their amygdala was active in seeing these frightful faces, and they were mislabeling 1 in 4. A subsequent study showed that these adults had made few errors when identifying fear. I think this has important implications in terms of trying to inhibit their own gut responses, one of the researchers said. The studies were taken to mean that teens were innately deficient in their ability to interpret the emotions of others in a social situation and therefore more prone to impulsive violence than adults. And this became a widely published and discussed story in science journalism, in everyday newspaper in the science section. So here's where the problem is. It turned out, however, that teens might not be so bad at detecting fear in others after all. When one of the original Harvard investigators, Abigail Baird, conducted additional trials with new photographs of faces, she obtained different results. She switched the photos from the dated black and white shots of people who resembled bad actors in B-grade horror films, the ones used in the first 2 studies, to color photos of more contemporary-looking people. When she did this, Baird's adolescents provided correct responses to almost 100% of the time. So the very structure of how the experiment is being set up must be considered to understand with accurate knowledge what's going on